So friends, look at the question. If 21 into x square plus y square plus z square is equal to x plus 2y plus 4z whole square, then x, y, z are in AP, GP, HP or none of this. Okay. Now, to solve this type of numerical, we'll use a very good trick, and this trick is known as Lagrange identity. Okay. So, for your better understanding, I am writing the trick here. Look at the tricks. The trick is, if a1 square plus a2 square plus till an square into x1 square plus x2 square plus till xn square. Okay, this is equal to a1 into x1 plus a2 into x2 plus an into xn whole square. So, this identity is known as Lagrange identity. So, if this identity happens, then we can say a1 is to a2 is to a3 is to till an. This is equal to x1 is to x2 is to x3 is to is to xn. Okay. So, using this trick, we can solve this numerical in a quick way. So, please look on the solution. We have 21 into x square plus y square plus z square is equal to x plus 2y plus of 4z whole square. Is it? This is the given statement, or you can say this is the identity. Now, we have to arrange this in the form of Lagrange identity. Okay. So, look how this 21 can be written as 1 square plus 2 square plus of 4 square. 4 square is 16, 2 square is 4 and 1 square is 1. So, 16 plus 4 plus of 1 is equal to 21, and x square plus y square plus of z square is there. Okay. And look, the right hand side is already in the arrangement, that is 1 into x plus 2 into y plus 4 into z whole square. So, this is in the form of Lagrange identity. Okay. Instead of a1 square, we have 1 square. Instead of a2 square, we have 2 square, like this. Instead of an square, we have 4 square. In the given trick, there are n number of terms inside this first factor. So, here 3 number of terms. Okay. So, similarly, instead of x1 square, we have x square. Instead of x2 square, we have y squares, and so on. And this is a1 x1 plus a2 x2 plus a3 x3, and like this whole square. Okay. So, we can say x is to y is to z according to the Lagrange identity. X1 is to x2 is to x3, like this, is equal to what? A1 is to a2 is to a3, like this. So, we have a1, a2, a3 is 1, 2, 4. So, we can say this is equal to 1 is to 2 is to 4. Okay. So, what does this refer? X, y, z are in GP. Okay. So, this implies x, y, z are in GP. If x, y, z are in the ratio such that they are in AP, then the answers will be AP. So, in this case, x, y, z are in GP. Okay. As 2 square is equal to 1 into 4, that is y square is equal to x into z. So, x, y, z are in GP. So, our correct option is option B. Understand? Very clear? Okay. Now, come to the next question. So, friends, now look on this question. We have to find the sum of this series till infinite number of terms. The series is 5 divided by 3 square into 7 square plus 9 divided by 7 square into 11 square plus 13 divided by 11 square into 50 square, like this. Okay. Till infinite term, we have to find the sum. And options are given in the board, that is 1 by 18, 1 by 36, 1 by 54 and 1 by 72. Now, to solve this numerical, we must look the series first. Look, the first term of the series is 5 divided by 3 square into 7 square. Now, 3 plus 7 is what? 10, which is just double of the numerator, that is 5 into 2 is equal to 10. And what is the difference of 7 and 3? It is 4. Similarly, look at the second term. 7 plus 11 is 18, which is just double of the numerator, that is 9 into 2 is 18. And the difference of 11 and 7 is again 4. Okay. Similarly, in the third term, the difference of 15 and 11 is 4. And sum of 15 plus 11 is just double of the numerator, that is 13 into 2, that equal to 26. So, we will use this observation to solve this numerical. Okay. So, look how to solve this numerical. The series is 5 divided by 3 square into 7 square plus 9 divided by 7 square into 11 square plus 13 divided by 11 square into 15 square, like this till infinite. Okay. Now, as the sum of the base factors of the denominator, that is 3 and 7, is 10 and the numerator is 5. So, we must multiply it and divide by 2 with each of this term. Again, as the difference of 7 and 3 or 11 and 7 or 15 and 11 is 4, so we must multiply it by 4 and divide by 4 with each of these terms. Okay, look, so what is the result finally? We must divide and multiply it by 8 with each of this term. Okay, so this become 10 into 4 divided by 3 square into 7 square. Look, 10 into 4 is nothing but what? 10 into 4 is 40. 40 by 8 is 5. Again, we can write 1 by 8 into 9 is 72. This is as 18 into 4 divided by 7 square into 11 square. Is it? Similarly, the third part can be written as 26 into 4 divided by 11 square into 15 square. Like this. Okay. Now, in the third line, this 10 can be written as 7 plus 3 and this 4 can be written as 7 minus of 3. So, 7 plus of 3 into 7 minus of 3 is what? This is 7 square minus 3 square. So, the numerator can be written as 7 square minus of 3 square. The denominator is 3 square into 7 square. Plus, similarly, this 18 can be written as 11 plus 7 and 4 can be written as 11 minus 7. That is why 18 into 4 can be written as 11 plus 7 into 11 minus 7, that is 11 square minus 7 square. So, we are writing this is as 11 square minus of 7 square divided by 7 square into 11 square. Okay. Similarly, the third term can be written as 11 square minus of 15 square whole divided by 11 square into 15 square plus dot dot till infinity. Clear? Now, what we can do? Look, this is equal to 1 by 8. This 7 square minus 3 square divided by 3 square into 7 square can be written as 1 by 3 square minus of 1 by 7 square. So, we are writing this is as 1 by 3 square minus 1 by 7 square. Similarly, the second term, that is 11 square minus 7 square by 7 square into 11 square can be written as 1 by 7 square minus 1 by 11 square. So, we are writing this is as 1 by 7 square minus of 1 by 11 square. Okay. Similarly, the third part can be written as what? The third part can be written as 1 by 11 square minus 1 by 15 square plus dot dot till infinity. Okay. Clear? Now, what happened? This become 1 by 8. Look, 1 by 7 square, 1 by 7 square are cancelled. Similarly, 1 by 11 square and 1 by 11 square are cancelled. Similarly, all of the term will be cancelled. Only the first term, that is 1 by 3 square, will be remaining and the last term will be what? This is 1 by infinite square. Is it? So, only this will be remaining. And we all know 1 by infinite square is nothing but what? 0. So, what is the answer? 1 by 3 square, that is 9 into 1 by 8, that is 1 by 72. So, our answer is 1 by 72. Very easy. So, the option is option D. So, option D is correct. I think it is very clear to you. So come to the next question. So friends, look, another very tricky question. If sequence an and sequence bn are there such that an is equal to x to the power 1 by 2 to the power n plus y to the power 1 by 2 to the power n, and bn is equal to x to the power 1 by 2 to the power n minus y to the power 1 by 2 to the power n, then we have to find the values of a1 into a2 into a3 dot dot till an, and here given n belongs to whole number. Okay, and options are given in your board. Now to solve this numerical, we'll use a very good trick and interesting trick also. Okay, so let's have a look at the solution. We have an as x to the power 1 by 2 to the power n plus y to the power 1 by 2 to the power n, and bn as x to the power 1 by 2 to the power n minus y to the power 1 by 2 to the power n. So if we make product of this, that is, better we write AR into BR. Okay, this is equal to what? X to the power 1 by 2 to the power R plus y to the power 1 by 2 to the power R into x to the power 1 divided by 2 to the power R minus y to the power 1 divided by 2 to the power R. You know this is nothing but a plus b into a minus b, so it will be a square minus b square. So we can write a to the power r into b to the power r is equal to x to the power 1 by 2 to the power r whole square, that is x to the power 1 by 2 to the power r minus 1 minus y to the power 1 by 2 to the power whole square, that is y by y to the power 1 by 2 to the power r minus 1. Okay. So what does a to the power r into b to the power r become? X to the power 1 by 2 to the power r minus 1 minus y to the power 1 by 2 to the power r minus 1. This can be written as br minus 1, because just check, if we substitute n by r minus 1, br minus 1 will be x to the power 1 divided by 2 to the power r minus 1 minus y to the power 1 by 2 to the power r minus 1. So we are writing this is as b r minus of 1. Okay. So we get a to the power a r into br is equal to br minus of 1. Clear? Now come to the question directly, which I have to find. We have to find the values of a1 into a2 into a3 into dot dot an. This can be written in the short form capital pi of ar, r from 1 to n. Pi means product, you know. So now we are writing a1 into a2 into a3 into dot dot till an can be written as what? Capital pi of ar and r from 1 to n. Symbolically we can write in this way. Now let's look what we can do. Now this pi of ar, r from 1 to n can be written as pi of r equal to 1 to n ar into br divided by br. That is, just we multiplied and divide by b and divide with br with this ar. Okay, clear? So ar can be written as ar into br by br. Now what is ar into br? We already find the value of ar into br is br minus 1. So substitute ar into br by br minus 1. Okay. So look, this can be written as pi of r equal to 1 to n br minus 1 by br. Okay. Now put r equal to 1, 2, 3 consecutively. So if we put r equal to 1, 2, 3, what becomes? This is b0 by b1 into, put r equal to 2 will get b1 divided by b2, then put r equal to 3 will get b2 by B3 like this. Dot dot till it is put r equal to n. This will be Bn minus 1 divided by B of n. Understand? Pi means product. Just we put first r equal to 1, we get B1 minus 1, that is B naught divided by B1. Then put r equal to 2, we get B2 minus 1 divided by B2, that is B1 by B2. Then due to presence of this pi sign, we have to put again multiplication sign. Then put r equal to 3, we get B2 divided by B3 like this, and we will continue till r equal to n. Then when we will substitute r equal to n, this become the last factor will be Bn minus 1 divided by Bn. Now let's simplify it. So when simplifying, what happens? This B1 B1 cancel, B2 B2 cancel. Similarly, all of these diagonally are cancelled. So what happened? What become the result? It is B naught divided by Bn. Is it? Now look, what is the value of B naught? Okay, we have Bn is this x to the power 1 by 2 to the power n minus y to the power 1 by 2 to the power n. So if we substitute n by 0, that is B naught, this will be x to the power 1 by 2 to the power 0, that is 1, minus y to the power 1 by 2 to the power 0, that is 1. That is what? X minus y, x to the power 1 minus y to the power 1, that is x minus y. So the value of B naught is nothing but what? X minus y. So substitute here. So we are getting it is x minus y divided by Bn. So we get it. So what is the answer? The value of A1 into A2 into A3 into dot dot An is equal to pi of AR, r from 1 to n, and this value is, we already find the x minus y divided by Bn. So this is our answer. Okay. And in the options, the option is B. So option B is the correct options. Clear? I think it is clear to you, and interesting questions. So come to the next question. So friends, let's come to another interesting question. We have to find the coefficient of x to the power n minus 2 in the polynomial x minus 1 into x minus 2 into x minus 3 dot dot till x minus n. Okay, and options are given in the board. Now to solve this numerical, we just apply the theorem of polynomials. So let's look. The polynomial given as x minus 1 into x minus 2 into x minus 3 into x minus 4 into dot dot till x minus of n. This is the polynomial given. Okay. So if we expand it by theorem of polynomial, the first term will be x to the power n, as there are n factor. The second term will be what? Minus of 1 plus 2 plus 3 plus dot dot till n into x to the power n minus of 1. Okay. Plus, what will be the third term? The third term will be 1 into 2 plus 1 into 3 plus dot dot 1 into n plus like this till n to n minus 1 into n into x to the power n minus 2. And in this way, if we proceed, the last term will be minus 1 whole to the power n into 1 into 2 into 3 dot dot till n. Okay. So this is just we apply here the theorem of polynomials. In short, this can be written as x to the power n minus, this is summation of 1. Summation of 1 means here I write just 1 plus 2 plus 3 plus dot dot till n into x to the power n minus 1. Okay. This can be written as summation of 1 into 2 into x to the power n minus 2. Okay. Then again minus like this. And what will be the last term? It is plus of minus 1 whole to the power n into 1 into 2 into 3 dot dot till n. Okay. So what does summation of 1 into 2 represent? It is represent that sum of the product of any two numbers taken from 1 to n in all possible way. Okay, that is 1 into 2 plus 1 into 3 plus 1 into 4 plus 1 dot dot 1 into n plus again 2 into 3 plus 2 into 4 plus 2 into 5 plus dot dot till 2 into n again like this. That is just sum of the product of any two numbers taken from 1 to n in all possible ways. Okay. So what is the coefficient of x to the power n minus 2? As we know, as we need the values of x to the power n minus 2, the coefficient of x to the power n minus 2 is basically summation of 1 into 2. Okay. So we are writing, therefore, coefficient of x to the power n minus 2 is lambda equal to summation of 1 into 2. So we have to just find the values of summation of 1 into 2. Okay. Now look how we can find the values of lambda. Now we know 1 plus 2 plus 3 plus dot dot till n whole square is equal to what? It is 1 square plus 2 square plus 3 square plus till n square. Okay. Plus 2 into summation of 1 into 2. We know this is. Now what is the value of 1 plus 2 plus 3 plus dot dot till n? We know this value is n into n plus of 1 divided by 2. Okay. Its whole square is there. Is it? Similarly, 1 square plus 2 square plus 3 square plus dot dot till n square, this can be written as what? N into n plus 1 into 2n plus 1 by 6. So writing this, n into n plus 1 into 2n plus of 1 whole divided by 6. Okay. Plus 2 into, here we writing lambda, because we already give the values of summation of 1 into 2 as lambda, which is the coefficient of x to the power n minus 2. So we have to just find the values of lambda. Okay. So simplifying it, look. So 2 into lambda can be written as n into n plus 1 whole square by 4. So we can write n into n plus 1 whole square by 4 minus of n into n plus 1 into 2n plus 1 by 6. So we are writing minus of n into n plus 1 into 2n plus of 1 divided by 6. Okay. So we can take common n into n plus 1 by 2 from both of these two parts. We can write 2 lambda is equal to n into n plus of 1 divided by 2 into n into n plus 1 divided by 2 minus of 2n plus of 1 divided by 3. Okay. Now just simplify this. 2 lambda will be, if we simplify this whole of this thing, we can directly written as n into n square minus 1 into 3n plus of 2 whole divided by 12. Okay. So what is the value of lambda? The value of lambda is obviously n into n square minus 1 into 3n plus of 2 whole divided by 24. Okay. So the value of lambda, that is the coefficient of x to the power n minus 2, is equal to n into n square minus 1 into 3n plus of 2 divided by 24. And in the options, B is the correct options. Okay. So in this way, we can solve this numerical in the quick way. Clear? Understand? Now come to the next question.